So we're another student-driven project focusing on parking. I'm Charles McNeil. I'm working on the communication system in our design.
Hi, I'm Philip Davey. I'm a EE major and I'm focusing on the microcontroller integration.
I'm Sad. I'm a computer engineering student and I'm working on the user interface and also assisting with the power system.
I'm Augustine Reyes. I'm a EE student and I'm focusing mainly on developing the power subsystems for our device.
So what we're trying to do is, rather than detect an entire parking lot at once and upload that data, we're trying to detect individual spots that can possibly be spread over a large area. Here at UTD, we have 8 different electric car charging stations. And they're spread out. There's one next to the visitor center, there's one near the library, and it can be difficult to figure out which one is the most available to you. So similar to other projects, we're going to have an online application where people can look up on their phone to figure out where they can go to charge their car. But we're trying to build individual devices that would be low cost and go onto individual spaces. And then they would network together using wireless communication so that we can have a network of these devices spread out throughout campus, trying to detect individual special parking spaces that have high priority. And so we basically split our each individual device into parts, where we have the power system, the sensor we're using, just a simple low power infrared sensor. And we have our controller, and the communication system is through LoRa transceivers, which is long range, very low power, which is what we're trying to use. And we have our user interface. A big part of what we're trying to do is have each individual module last a long time before it needs the battery replaced or be replaced as a whole. So we're trying to stay very low power, and we're also trying to use solar power so that these things have a very long life. And we also want to be very accurate in when you look on the website that you can be sure that if it says it's taken, it is taken. And so that's what we're trying to do to help UTD's campus. So if y'all have any questions.
You know, by the way, you guys did a really good job on introducing who's working on what. You know, that was one of the things that they gave us to evaluate. You know, one of the things that nobody's mentioned is you know, you got this web interface, but you know, it's really not a good idea to be on the web when you're driving. Has anybody done the Hey Siri, where's the nearest parking lot spot on your app? Have you guys looked into doing something like that so you can get the verbal, you know, give me directions to the nearest open specialty spot?
We haven't looked into doing that as of now, but we'll definitely do that in the future semester.
I think
definitely sounds like a good
for all you,
idea.
for the many guys that are working on parking spots,
Yeah.
I think that would be a good feature.
Yeah.
And also, since we're focusing on these specialty spots on campus, hopefully people can look up on their way to their car, like while they're walking. And since the spot is only maybe a few minutes away, they can be reasonably sure that if it says it's open, when they get there, it'll still be open.
Yeah.
So they don't have to be driving
Yeah.
while trying to access it.
I think what they're doing at the DFW airport, where, like, you know, as you're getting into the lot, it says how many are occupied or how many vacant, and obviously UTD probably has a bit more complexity, like you have purple or you know, green, yellow, orange spots and all. So maybe it needs a bit more you know, software or hardware going into it, but that's probably something to look at. I don't know if, as we are driving in, how can we pay attention to, you know, our phones to look for, so it has to be more visible out on the street than on a computer or a phone, I think. But good job.
The aim of the user interface was so that we didn't have to drive around campus to go to the parking signs.
Right.
For instance, they have those signs outside the parking garages that say they have this many of each ones.
Right.
But how do you know that the parking garage has any spots at all without
Until
actually
you go
going
there.
to
Especially
the
with
first?
priority spaces, with the lack of spaces around campus.
Right, and the contrast to that is, like, how often do you have to, while driving, look at your phone to see which lot you have to pick?
Mhm.
Right, as you are heading closer to UTD, should I go to north lot or south or east or west? You have to open while you're driving or
Yeah.
stopped at a
That's why I wanted to, hey Siri, tell me the nearest one.
Right.
Yeah.
What's not clear to me here is where you intend to put the sensor, because you're asking for correct readings at up to half a meter, which is not very long.
So
putting it on the ground?
Ideally, yeah. Ideally, it would be a small device that has a casing that can withstand being driven over. And it would be on the ground, and so you would just have to detect if there's something over top of it.
Is there a reason you're not trying to mount it to the charging station itself?
Well, we could do that since we are mostly focusing on the charging stations, but in more general, if you want to expand this to, for instance, also like handicap parking or something like that, where you wouldn't necessarily have one of those stations, we were trying to keep it a little more general in that sense. But for just the charging stations, they could be mounted anywhere that would be pointing towards the empty or full spot.
I understand you just picked the hardest place to put the sensors.
Yeah,
It just
exactly.
seems like you put on a post or something like that at the end of the parking spot.
Thank you.
All right, thank you very much.